This video is part of Firm Theory Cost. In this video, I will show you how to graphically derive a labor demand curve. Before I get into input demand, let's take a step back to, in consumer theory, deriving demand for each of the goods. Remember how I showed you that we could derive the demand function for a good like beer by performing the following exercise. Start with the original optimal utility maximizing bundle and the quantity of beer at that bundle, given the underlying price. Allow the price of the good to fall and see how the consumer responds by moving to a new utility maximizing bundle, and at that new utility maximizing bundle, noting the new quantity demanded. These 2 points can be represented on the demand curve for beer because each represents a certain combination of price and quantity. We're going to do something very similar, but now we're going to look at input demand using isoquants and isocost lines. To derive a labor demand curve, first start with cost minimization. Here we see a firm minimizing the cost of 100 units of output by using L1 units of labor, K1 units of capital, and incurring a cost of total costs of $1. Labor demand is an exercise in what happens to the amount of labor the firm will choose as the price of labor changes, holding the rental rate constant. So let's do that. Let's change the price of labor. Let's let the wage rate fall to $8, but let's hold the price of capital constant. Just like in consumer theory, when the price of the variable on the x-axis falls, the isocost line rotates out. The firm does have a constraint that output has to be fixed or held constant at 100 units. With this new flatter isocost line, there are 2 input bundles on it that also satisfy the constraint that output is 100 units. However, neither of these input bundles is cost minimizing, which I know because both bundles are points of non-tangency. The firm does have a constraint that output has to remain at 100, but it is able to choose its inputs in order to minimize the cost of that level of output. Indeed, there's a lower isocost line that is just tangent to the isoquant Q equals 100 at now an input bundle that has L2 units of labor and K2 units of capital. What I want you to see from this graph is that lowering the price of labor, called the wage rate, led to a substitution towards labor and away from capital, which is not surprising because we are exactly seeing a substitution effect in firm theory. From this original bundle, L1K1, to the new bundle, L2K2, we have held output constant, not utility in firm theory, but now output is being held constant, and we allow the slope of the isocost line, or the relative input price ratio, to change. Changing the price ratio, holding now output constant, is exactly what a substitution effect is. This is summarized by my slide, where first we see the firm using input bundle X, then the wage rate falls, swinging the isocost line out, but because the firm is still going to keep output constant at 100 units, and the wage rate is lower, the firm is going to be able to spend less money to produce the same amount of output. And so the isocost line, after swinging out, comes back in a parallel way, and the firm moves from bundle X along isoquant Q equals 100 to bundle Y along the same isoquant, thereby substituting towards labor and away from capital. In summary, a labor demand curve shows how the firm's cost minimizing quantity of labor varies with the price of labor, holding the rental rate or the price of capital and output constant. Here we see that as the firm's wage rate changes, it moves from one cost minimizing bundle to another. And what the labor demand curve does is match up for each wage rate the cost minimizing quantity of labor. And what we get when we connect those dots is the labor demand curve.